Yeah, ladies and gentlemen, welcome to the fourth speech or fourth presentation of the Linkwitz Parlor this year. As you know, we are focusing on this series of speeches on the 6 major problems or 6 major issues that we face in the playback chain, ranging from the artist's performance up to the conservation of that performance, up to the replay of that performance on the loudspeakers. So as I said, everyone can have different goals in what they expect from a loudspeaker when they are doing the replay. Somebody just wants to sit in front of his loudspeaker with a glass of wine and enjoy the evening and have the most pleasant sound, tube sound, whatever. And the other one is looking for a most authentic reproduction from what was happening in the recording venue, and seeks for the maximum transportation, so to speak, or transfer of the emotional musical aspects that the artists were trying to bring to us, and without further interference of lots of gear or other stuff that make our sound euphonic or pleasant or whatsoever. Siegfried Linkwitz, the designer of these speakers, was surely in that ballpark where you want to have the best possible reproduction of an authentic and transport of the intent and of the artist, that the message the artist wants to convey to us. And in that respect, we already saw Barry Diamond's presentation on how the recording should be done in order to have the least spatial distortion, the least tonal distortion, timing distortion. And Jamie Howard already talked about what can go wrong in the conservation and the post-processing process on that one. And in the third speech that you heard from my side on the other room was about the imaging of the speakers and the size of the image that is going to be created in the virtual sound stage of any instrument, and on the issues with producing bass in reverberant fields, in reverberant rooms, and what the big advantages are in respect with dipole speakers, why they are performing so well in reverberant rooms, what their positive aspects are on that. And now for the fifth part, this was the dynamic that was also covered by Barry. Dynamics, which is the fight against loudness war mostly, and the right recording levels. And the sixth part is the issues in the digital domain, which is quite new to audio still. But on the other hand, we are still seeing very much going on the analog sector with turntables and recently with tapes as well. But I'm convinced that recording formats that are basically analog, like DSD, and the further development like DSD 256, the quad DSD, can bring us enormous joy and fidelity in the recording and replay chain, and we experienced that in the experiment that we did, and some of you heard already in the December recording that Frans de Wond did in the Netherlands. It was a pure DSD recording without post-processing and replayed here with just the same result as we experienced in the recording room. It was one-on-one, the placement, the tonality, the musicians, the artists were standing in the control room and couldn't believe it, how accurate and authentic that journey was. Now the sixth part with I'm really happy to have Jussi Laako at the party. Jussi is one of the most knowledgeable experts on DSD and DSD processing. He's the inventor of the HQPlayer you may have heard of. That's around now for quite a while and more developed. We are using the HQPlayer embedded here on a mediocre laptop, and we are feeding it via an NAA endpoint. That's an endpoint that allows you to put that computer somewhere else in the room. And feeding it to a TNA 200 DAC, which has a separate pipeline for DSD, and it's a fully discrete pipeline for DSD. And this is feeding our system from there on analog crossover amplifiers, 10-channel amplifiers in these power boxes going to the speakers. This is what we're gonna set up here, and Jussi will bring you closer to what is DSD and PCM, what's the difference about it, what are the drawbacks, PCM, DSD, what is happening in a usual recording, how the usual recordings done in DSD or PCM, or first DSD, then converted to PCM whatsoever. There's a lot of confusion in the audiophile world. What is going on, what are the drawbacks, things, and even up to the professional level, not everybody is aware of what is possible today with DSD. And it has developed quite a while since the times of SACD, which was DSD 1 time, or DSD 64. Things have developed quite a lot, and you can find no better people out there, no better presenter for this topic as Jussi Laako. Welcome, Jussi.
And good afternoon to AXPONA. I'm going to talk a bit both the recording side and the playback, and also the production part, and how the digital processing, especially for DSD, happens, and what different approaches can be taken on it, and what in particular HQPlayer, which is my software, can do on this area. Okay, so a bit introduction about myself. So I've been developing software for quite a long time, and also designing hardware. So for audio and audiophile things, I started first with some of my own amplifier designs in 1990, and then I designed my first DA converter in 93. And that was the first DA converter was based on the electronics available at that time. And then I had quite a bit of DSP algorithms ready already in 98 that I originally made actually for different purpose. But I realized that actually I could use these algorithms for audio playback and improve what the DA converters in those days were able to do by running the algorithms in like a normal computer, instead of having some chip inside a DA converter or a CD player. So the HQPlayer project was started in 98, and it was mostly for myself and like internal development for 10 years. And after 10 years, I considered that it was like ready to be launched to the public. So I started, when the software was ready in like 1.0 form, I started the company in 2008. And at the same time released also the HQPlayer 1.0. And that was still like simple PCM upsampling software that could play CD, directly from disk, do upsampling and send it to a DA converter. And also the computers in especially 98 couldn't do nearly as much as those can do today. So eventually HQPlayer was first player application to play DSD from computer. Before that, DSD was solely for SACD. And then later I added DSD upsampling from PCM, conversion from PCM to DSD output in real time. And then also more recently digital room correction for DSD without making sampling rate conversions. So that's quite heavy process, even for DSD64, but even more so for DSD256, because the data rate is so much higher than, let's say, Redbook PCM or some high-res PCM. And now in recent HQPlayer releases, there's also like real-time analysis, so you can watch spectrogram for the source content, and it also works for DSD content. So you can see like real-time metering for the input data, analysis for the input data, like for different errors and such, and also watch the spectrogram, so you can see if there's like some issues or if it looks like fake high-res or similar. That was requested many times from me by the customers. And then the recent addition was also the DAC corrections, so corrections for different DA converter models and the errors that they have, for example, in both the digital and analog sections, so that the output signal is even more accurate into the actual wanted signal rather than being distorted or similar. And then also volume leveling was added recently, so that the analysis for the library and it can do like replay gain for DSD content as well. Okay, so to the actual topic. First, on the recording side, the on the top in the diagram, there's a traditional like high-res recording chain where there's delta sigma ADC, the modulator takes the analog input and then it outputs typically, like for example AKM chips, output 2 bits at 128 times the base sampling rate, for example 44.1. So this is equivalent to DSD 128 rate. And then it gets converted to PCM inside the chip with not so advanced digital filters. And then there's also a DC block in the chain to remove DC from the input, and then it goes to the workstation. And then in the DXD case, it's similar, but the output rate, just the output rate from the PCM conversion is higher, so it's 352.8 kilohertz instead of a typical 96 kilohertz of most high-res recordings. And then for DSD, it's the idea of DSD is that since all the ADCs and DA converters these days are delta sigma type, so why would we convert it to PCM instead of passing it through straight in the original data format that was from the actual analog to digital conversion stage. So we take just the output from the actual analog to digital conversion stage, and that's the DSD recording side. it's for historical reasons it's 1 bit instead of 2 bits, but it doesn't make much practical difference. And then, so the typical issues in this PCM case is that the digital filters that convert the modulator output, the high rate modulator output that looks like DSD, when it's converted to PCM, the digital filters inside the chips are not so great. Like this 85 decibel attenuation is from the AKM AK5572 chip, for example, that is quite popular in pro audio recording systems. And even the sharp filters there are not so sharp in the end. So if the ADC is set to record 44.1 kilohertz, so the CD rate, then the high frequencies that go above the 22.05 kilohertz, which is the maximum that the 44.1 kilohertz can reproduce, the frequencies that go above it fold down to the baseband and get mixed with the actual wanted signal. So those are distortions. And these distortions on these chips, for example, go down to 18 kilohertz. So whatever goes from 18 kilohertz upwards to 22.05 contains mixture of the wanted signal and then some errors that are aliased down from the higher frequencies, because the audio input that comes to the converter doesn't like suddenly stop at 22.05 kilohertz. It goes much higher, typically like 50 or 60 kilohertz. And then if it would be sharper, the ADC digital filter, it would cause ringing in the time domain. So steeper the filter, longer it gets in time domain, and then it starts spreading the energy over longer time period. And that sounds bad, especially in transients and like short-term signals. If you play continuous sine tones or have like some, let's say, organ music where there are no sharp changes, then it doesn't matter, but it matters for drum hits and like usually percussion and that kind of inputs. And then these DC block filters are also problematic in the ADC, and this is actually something that still applies whatever kind of recording system is used. Then the DC block is a bit problematic. So, and then there are other issues in the ADC, also like clock jitter that ends up being embedded into the actual recorded data. It becomes part of the recorded data. And that's also one problem. Okay, so then if we like zoom out and consider the entire playback chain, what happens from the recording to the playback and going to the amplifiers. So we have the ADC running at 128 times the base rate, and then it gets converted to PCM and to double rate, so 96 kilohertz, for example. Then you get editing and mixing, like let's say in Pro Tools, and then that's transported to mastering, and that can be done, for example, in Wavelab or similar, and goes through some EQ plugins and dynamic range compression typically. And then for CD, for example, it's converted then to 44.1 kilohertz, so it goes through yet another rate conversion. Then you play it out to the DA converter, which again converts it, oversamples it or upsamples it to higher rate, to 256 times the original rate, and modulates it back to delta sigma modulation, so it becomes again like a DSD. So you have a lot of conversion on this path, and all this, none of these conversions improve the quality. So it's at most it retains the quality or it makes it worse. And then in the DXD case, we still have this, on the source side we have the same conversion, but the output rate is just higher. It's 8 times the base rate. Usually the editing, mixing and mastering all happens in typical DXD productions. It happens in one go, and then that DXD can be delivered, for example, as a FLAC file or similar to the consumer or customer who plays it out, and then it gets again converted similarly like the 256 times the base rate and goes through the delta sigma modulation. And then in the DSD case, we just, if in this example it's DSD 256, so we just retain the sampling rate throughout, also through the editing and mixing, and this is something that is not widely available at the moment. So most DSD productions go, either they are direct recordings that are not mixed at all, or don't go through much editing at all, or a lot of the content ends up converted to DXD mixed and then converted back to DSD 256, for example, for output. So, but in the past, so currently the only commercially currently available, as far as I know, tool for doing this is Pyramix from Merging, and that uses DXD. And then earlier there was Sonoma Workstation, which can do only DSD 64, but it can do this full chain without rate conversion, so it can retain the DSD 64 rate. But it cannot do any other rates because it uses special hardware. So in the PC you need to have special PCI card that handles all the DSP done for this. So then my solution, I was discussing with many production people who wanted to do mixing and for DSD recordings, including DSD 256. Pyramix cannot do it. I had the algorithms to do it, but I don't have the user interface, like full audio editor user interface. So how it ended up being is that I created HQPlayer Pro, which is essentially file processor. It processes source file to output file. So it's a lot like HQPlayer currently, especially looks a lot like HQPlayer desktop, but it has a number of